universe begins in silence. No sound crosses the vacuum, yet everything moves. Stars orbit unseen centers. Galaxies turn like slow whirlpools in a black ocean. And entire clusters drift through space as though following invisible instructions. For billions of years, these motions repeat without decay, without fatigue, without the slightest hint that the engine of the cosmos ever winds down. Planets trace their ancient paths, moons circle their hosts, and the very fabric of space bends just enough to hold them all in rhythm. There is no noise, no friction, no loss. Only gravity, the quiet sculptor of time. In a world where every fire burns out and every wave fades, gravity endures unchanged. The stars that ignite will one day cool, their light dissolving into darkness. The atoms that make them obey the restless dance of electromagnetism, a force that sparks and dissipates in endless cycles of charge and release. Even the strong force within atomic hearts must eventually surrender to decay. Yet gravity, patient and unhurried, persists. It does not rust, it does not weaken, it does not spend itself. It binds galaxies for eons, as if eternity itself were its natural domain. Consider a planet orbiting its star. Around and around it goes, tracing the same perfect ellipse century after century. Nothing fuels its journey. There is no engine, no current of energy pushing it forward. Its motion is sustained entirely by geometry. It is as if the planet is falling forever, yet never reaches the bottom. On Earth, a falling stone releases energy, but the orbit of a world is different. It is the eternal fall that never ends. The motion costs nothing because it requires nothing. Gravity, unlike wind or magnetism, does not give or take from the system. It only defines the shape of motion. Other forces consume. When electric currents flow, heat blooms. When friction grips, energy scatters into random motion. Even light, which travels with divine precision, loses intensity as it spreads. These are dissipative processes, where order becomes disorder, where potential becomes waste. But gravity has no friction, no resistance. The moon does not grind against its orbit. The Earth does not tire as it circles the sun. A galaxy's spiral remains graceful over cosmic ages, a choreography too vast for entropy to touch. The very persistence of these motions poses a question. If everything else in the universe wears out, why does gravity not? The question seems simple, yet carries the weight of all physics behind it. How can a force be eternal? Does it consume energy we cannot measure, or is it something deeper than energy itself? To answer, we must first look at the nature of what we call a force. For most of history, humanity saw forces as invisible hands that push and pull. The apple falls because the earth pulls it. The planets circle because the sun tugs them along. But this view, elegant as it was in Newton's age, carries a hidden assumption that gravity does work, that it spends effort to maintain the order of orbits. The truth is subtler. What if gravity does not act at all? What if it simply is? The motions we attribute to it might be no more than the natural shape of the universe's geometry. In that case, there is no energy lost because there is no energy spent. The planets move not because they are forced to, but because motion through curved space looks like an orbit. The universe, in this sense, is not a machine that burns fuel. It is a pattern that unfolds. Imagine the galaxies as ripples frozen in time. Each star follows its curvature in the cosmic landscape, just as a marble would roll along the contours of a bowl. The marble does not need to be pushed to follow the curve. Its motion is dictated by shape, not effort. In the same way, gravity might be the manifestation of the universe's architecture, a design so perfect that movement and stillness are two sides of the same equation. The cosmos, then, is not powered by gravity, it is shaped by it. When astronomers gaze through telescopes and watch worlds in motion, they are witnessing the universe's great economy at work. every other force burns, collides, or decays. Gravity merely arranges. It guides stars to form, compacts dust into planets, and sets their orbits with a precision that endures long after their suns have dimmed. The energy we see in motion is not gravity's own. It is the system's energy, rearranged but never diminished. Like a conductor who never plays a note, gravity orchestrates without producing sound. If one could stand beyond time and watch the universe evolve, this quiet persistence would become the clearest signature of gravity's nature. From the first collapse of matter after the Great Expansion to the last orbit of a dying planet, the same law holds. There is no wear, no exhaustion. The fabric of space adjusts and rebalances endlessly. Even when stars collide or black holes merge, the loss is not true loss. It becomes the music of space-time itself, carried away as waves that never fade into static. To understand why gravity never wastes energy, one must let go of the notion that it is a force at all. It is not a push, not a pull, not an interaction transmitted by a particle through space. It is the geometry of space itself, the way matter tells space how to curve and space tells matter how to move. When we say gravity acts, what we mean is that the universe has a particular shape, and everything within it must follow that shape. Once this idea is seen clearly, the mystery begins to dissolve. There is nothing for gravity to spend. It is the form of motion itself. This realization leads us to the threshold of Einstein's vision. The world he revealed a century ago is not governed by invisible strings tugging at matter, but by the deep structure of space-time. Mass and energy tell space how to curve. Curved space tells mass and energy how to move. The orbits that appear eternal are simply the straightest possible paths in a curved world. In such a universe, energy conservation is not enforced from outside. It is written into the geometry itself. And yet, this raises a deeper wonder. If gravity is geometry, then why does the geometry never fray? Why do galaxies still spin, eons after their birth, without losing the rhythm written into their orbits? The answer lies not in hidden engines or mystical replenishment, but in the nature of the space-time fabric itself. Smooth, self-consistent, and immune to the forms of decay that afflict everything built within it. The universe, in its silent balance, does not allow gravity to waste energy, because it is gravity's own structure that defines what energy means. In the endless dialogue between motion and stillness, gravity speaks only in form. It guides without touching. It shapes without consuming. Every orbit, every fall, every rise of a tide whispers the same message through the ages, that the universe's most powerful architect never expends what it creates. The silence that endures between the stars is not emptiness. It is perfection, the unbroken geometry of existence. In the quiet corridors of cosmic time, gravity continues its wordless work. Stars are born in clouds of gas that drift for millions of years before collapsing under their own weight. Yet nothing about that collapse wastes a single fragment of energy. The potential stored in the separation of atoms converts perfectly into motion, heat, and light. The dance is entirely within the system. Gravity does not intervene as a spender or receiver of energy. It simply permits the transformation to unfold along the lines it has drawn in space. Each movement, from the slow drift of nebulae to the fierce ignition of a sun, is an act of perfect accounting. Imagine a dust grain floating within a molecular cloud. Over long ages it drifts toward another grain. Their meeting seems inevitable, yet no energy is lost in the approach. The grains fall together because the space between them curves slightly inward. Their fall is simply the shortest route through the geometry they inhabit. As billions of such particles join, a star takes shape. The brilliance that emerges is not energy granted by gravity, but energy revealed by compression. The universe does not pay for light. It simply allows the structure to concentrate and release what was always there. Gravity's role is architectural, not mechanical. Even the grandest structures obey this rule. In the core of a galaxy, billions of stars orbit a common center. They swing around like a vast luminous storm, yet the system endures without visible fatigue. The arcs of motion are determined entirely by the space-time curvature carved by the galaxy's mass. As the stars trace those curves, they do not consume a reservoir of gravitational energy. They merely follow the landscape, as rivers follow valleys. The form endures, the flow persists, and the system remains in equilibrium until external events disturb it. No heat is lost to friction. No force erodes the geometry. Gravity holds without holding on. If one could slow time to a crawl and watch the orbits of planets, stars, and galaxies, their stability would appear almost unnatural. There are no hidden engines adjusting their speed, no cosmic technician correcting errors. Their paths are self-correcting because they are self-consistent. When an object moves through curved space, its trajectory automatically aligns with the geometry. It cannot stray without external influence. This is why gravity feels eternal. Its precision does not depend on maintenance. It arises from the definition of space itself. The universe cannot forget how to curve. Yet to human senses, accustomed to the decay of all things, this perfection feels alien. We know the warmth of friction, the dulling of motion, the inevitable slide towards stillness. On Earth, no motion lasts forever without replenishment. A pendulum stops, a wheel slows, a flame gutters. We equate persistence with expenditure, but the cosmos has no such boundaries. The motions of celestial bodies are sustained not by an ongoing input of energy, but by the absence of anything that could drain it. There is no medium thick enough to slow them, no resistance to their path. Space itself offers nothing to absorb the motion, and so the motion continues. This understanding transforms the way we see the universe. Gravity is not a consumer of energy, but a curator of relationships. It determines how matter interacts without taking part in the exchange. It is a law that operates without cost. When we say that gravity pulls, what we truly mean is that matter follows the most natural curve available to it. The term pull is a human simplification, a remnant from the age when unseen forces were imagined as invisible ropes. Einstein shattered that illusion, revealing that motion through space-time is not compelled, but allowed. Think of a comet looping around the sun. For thousands of years it travels the same route, diving inward and flinging outward again, a frozen messenger from the early solar system. It does not require an engine to accelerate, nor does it burn fuel to climb back into the dark. Its path is a perfect compromise between kinetic and potential energy, with one transforming into the other and back again. The total remains constant. Gravity oversees the exchange but does not participate. It is the silent referee ensuring the rules are kept, the conservation intact. Even when gravity appears to act violently, such as in the collision of stars or the collapse of a massive body into a black hole, the process is bound by the same principle. The energy radiated as light or gravitational waves is drawn from the system itself, not from gravity as an external source. When two black holes spiral together, they emit waves that ripple through space, carrying away a small fraction of the total mass energy. Yet even here, the loss is orderly. It is not waste, but translation. The energy remains within the fabric of spacetime, merely redistributed into motion elsewhere. This idea unsettles our intuition because we are accustomed to seeing energy in terms of use and loss. But in the cosmic ledger, gravity keeps perfect balance. There is no inefficiency, no residue. What seems like the slow unwinding of orbits or the merging of systems is simply energy taking on new forms within an unbroken whole. The universe as a system neither gains nor loses. It merely reshapes itself endlessly, guided by the curvature of its own existence. To see this clearly is to recognize the profound stillness behind all motion. Every orbit, every fall, every wave is part of a grand equilibrium. The planets do not age from their revolutions. Galaxies do not tire from their rotations. The same mathematical precision that governs the trajectory of a thrown stone governs the swirling of superclusters. And through all of it, gravity remains what it has always been, the framework within which energy can transform without ever disappearing. This is why gravity feels eternal. It has no fuel to burn, no friction to overcome, no medium to consume. It simply exists as the shape of motion itself. The cosmos may expand, cool, and evolve, but the curvature that defines its structure persists as long as space and time exist. Even if all stars fade and all matter decays, the geometry of what once was will remain, etched into the fabric like ripples that never fully vanish. Gravity does not die because it was never alive. It is the condition of reality. And so the question that began with wonder, why gravity never wastes energy, turns into something deeper. Perhaps gravity is not a phenomenon within the universe, but the universe's own way of existing. It is not a player on the stage, but the stage itself, the silent framework upon which all acts unfold. To understand this is to glimpse the profound unity between matter, motion, and space, a unity that no other force can claim. In that realization, the silence of gravity becomes the clearest voice of all. The story of gravity deepens when we realize that its stillness is not emptiness. Beneath every orbit and every fall lies a dialogue between space and time, so intricate that even light bends to join the conversation. When a ray of sunlight curves around a planet, it is not pulled but guided, tracing the shortest route through warped geometry. The bending of light, the slowing of time near massive bodies, the cosmic web connecting galaxies, all are expressions of a single truth. Gravity is the shape of existence. It does not act on the universe, it defines it. From this perspective, energy itself becomes a local language, a way to describe exchanges within the larger whole. When an apple falls from a tree, we say it gains kinetic energy while losing potential energy. Yet neither is created or destroyed. Both are facets of the same invariant total. Gravity facilitates the transformation without paying a price. The same applies to stars orbiting the galactic center, to moons circling planets, and even to the great cosmic dance of galaxy clusters. The laws that govern them are indifferent to time. They do not corrode, they do not expire. This permanence is not born of resistance but of harmony. In the mechanical world we know, engines, fluids, collisions, energy leaks into forms we cannot easily recover. Heat, sound, radiation, they mark the loss of usable order. But gravity has no surface to rub against, no particles to scatter from. It is the cleanest mediator imaginable, allowing energy to flow within systems without subtracting from the total. The very absence of a medium is what grants it this perfection. It moves nothing and yet moves everything. Even in the violent heart of the cosmos, where black holes twist the geometry of space into near singularity, the same conservation holds. The swirling matter that vanishes beyond the event horizon does not erase its energy. It alters the shape of space-time. The horizon grows, recording the mass and spin of what it consumes. The information, though hidden, remains encoded in the curvature itself. Gravity, even at its most extreme, wastes nothing. It is the keeper of all accounts, ensuring that the balance of the universe never tilts. This discipline extends across scales. The falling apple and the orbiting galaxy obey the same rule, though their realms differ by unimaginable orders of magnitude. The apple falls because space-time near Earth curves downward. The galaxy spins because space-time on a cosmic scale forms a vast well around its core. Both motions arise from the same geometric principle. There is no boundary where gravity stops being exact. There is only the smooth continuation of curvature from one level of existence to the next. That unity is what makes gravity seem eternal, not a force among others, but the grammar of motion itself. To watch this play out is to glimpse the deep patience of the universe. The planets will keep their paths long after the sun fades into a white ember. The orbits of distant stars will persist when the galaxies have stretched thin across the expanding cosmos. Even the faint afterglow of the Great Expansion travels along curves set in the first moments of creation. These paths are not maintained by energy expenditure. They are simply the continuation of an initial condition within a flawless geometry. Once space takes on a shape, motion follows it effortlessly, like a melody repeating through eternity. Our minds, trained to expect decay, struggle to imagine such persistence. We are creatures of thermodynamics, born in a world of heat and loss. Yet gravity whispers of another order, one that is not bound by the same entropy that governs matter and light. It shows us that perfection, though rare, exists in the structure of the universe itself. Where other forces transform and diminish, gravity simply endures. It carries the imprint of every motion without ever wearing down. If one listens closely, there is poetry in this endurance. Gravity does not fight chaos, it organizes it. It takes the random distribution of matter and shapes it into stars, planets, and galaxies. It creates islands of order in an ocean of entropy without ever spending a drop of energy to do so. Its influence reaches everywhere, yet it remains invisible. The stars shine, the planets spin, and space hums quietly with curvature. Every atom obeys, not because it is compelled, but because the structure of the cosmos leaves no other option. Gravity's command is not one of dominance, but of inevitability. At the heart of this realization lies a paradox of beauty. The weakest force is also the most enduring. The most silent one governs the loudest phenomena. From the fall of dust grains to the collision of supermassive black holes, gravity provides the rhythm to which the universe moves. Its laws are so elegant that no energy is ever wasted, no motion ever meaningless. Every event folds perfectly into the next, a grand composition without loss. To contemplate this is to sense the underlying symmetry of all existence, a symmetry so perfect that it feels like eternity made visible. The chapter closes as the stars continue their patient revolutions. Around every sun, planets move in endless arcs. Around every black hole, light bends in silent reverence. The universe expands, yet the harmony remains. Gravity does not fade with distance or time. It simply changes scale, adjusting its geometry as the cosmos evolves. And so, from the smallest stone to the grandest cluster of galaxies, the same quiet hand guides all things, never tiring, never wasting, never lost. It is the silence that binds the infinite. Einstein's vision began with a simple question: what if gravity is not a force at all? For centuries, we believed that objects pulled on each other through invisible threads of attraction. Newton's law explained how planets moved, how apples fell, and how the moon stayed in orbit. Yet, even in its perfection, Newton's world had a flaw. It could describe motion, but not explain what caused it. Why should one mass reach across the void to affect another? What was the medium of that mysterious pull? The answer, when it came, changed the nature of reality itself. Einstein saw that what we call gravity is not a push or pull, but a reflection of shape. Space and time are not separate backgrounds upon which events unfold. They are woven together into a single fabric, whose curvature determines motion. A planet orbiting its star is not being tugged around a circle. It is following the straightest possible path through curved spacetime. What appears to us as acceleration is simply geometry made visible. The Earth does not need an engine to maintain its motion, just as a marble rolling around the inside of a bowl requires no constant push. The path is written into the surface itself. This insight dissolves the mystery of gravity's effortlessness. In Newton's world, motion required forces, and forces implied expenditure. Something had to act, to apply energy, to maintain balance. In Einstein's world, motion becomes a consequence of form. An orbit is the natural expression of spacetime's shape around a star. The planet is in free fall, moving along a geodesic, the straightest possible line within that curvature. No work is done. No energy is spent by gravity. The system evolves because that is what the geometry dictates. Imagine space as a vast ocean of fabric, smooth and continuous. Place a heavy object upon it, and the surface dips, creating a valley. Smaller objects move along the curved contours of that valley, their motion guided by the topography. They do not roll because they are pulled, but because that is the natural route. The dip is not a physical hole, but a description of how distances and times behave in the presence of mass. In this view, gravity's power lies not in action, but in definition. It determines how the universe measures itself. This geometry is dynamic. When matter moves, the curvature shifts with it. A passing planet slightly reshapes the space around it, altering the paths of nearby bodies. Yet this interaction does not drain energy. The curvature adjusts like ripples on a pond that never loses its surface tension. The waves move, the form changes, but the total energy remains conserved. The geometry of motion, once established, carries its logic forward indefinitely. This is why the cosmos runs without friction. It is a self-consistent system, perfectly tuned to preserve balance. If we could perceive spacetime directly, we would see planets tracing elegant spirals through a four-dimensional landscape, their paths smooth and inevitable. We would see time slow near massive bodies and light bending along arcs that seem to curve of their own accord. The sun does not pull on the Earth. It shapes the road the Earth must travel. Each second of that journey is effortless, requiring no input from the star. The geometry itself is the mechanism. In this realization lies gravity's true purity. Other forces rely on exchange, the trade of photons in electromagnetism, the exchange of gluons in the strong interaction. They are mediators, carrying quanta of energy between particles. Gravity, however, at least in its classical form, needs no messenger. The curvature of spacetime is the interaction. There is no separation between the field and the structure of reality. It is this unity that grants gravity its endurance. Nothing external can sap its strength, because there is nothing external to it. It is the arena and the actor, the stage and the play. When astronauts orbit Earth, they experience weightlessness, not because gravity vanishes, but because they are following the natural curve of spacetime. They are in constant freefall, perpetually moving along a path that space itself defines. Their motion feels effortless because it is. The curvature of spacetime provides direction without requiring energy. The same principle applies from the smallest satellite to the largest galaxy cluster. Everywhere, geometry dictates motion, and motion confirms geometry. This concept carries profound implications. It means that the universe conserves energy not by restraining loss, but by being constructed in a way that forbids it. The equations that govern spacetime, Einstein's field equations, ensure that energy and momentum are locally conserved. The geometry cannot fray or leak because it defines the very metric by which loss would be measured. Gravity cannot dissipate energy because it is the condition under which dissipation itself is understood. What we call stability is simply geometry refusing to unravel. To understand this is to see motion as a kind of grace. The planets do not resist falling into the sun. They are falling forever and never arriving. Their continuous motion through curved spacetime is the purest example of harmony in physics. They need no fuel, no correction, no maintenance. The curvature holds them in eternal dialogue with the central mass. When we look up and see Jupiter tracing its steady path, we are watching geometry made visible, the logic of the universe expressing itself without cost. This vision transforms our understanding of what motion means. Every swing of a pendulum, every orbit, every free-falling object is an expression of the same geometric principle. The apple falling toward the ground is following a space-time geodesic that leads it from branch to soil. The Earth's surface interrupts that natural path, creating the sensation we call weight. If the planet were not there, the apple would continue, unopposed, along the curve dictated by Earth's mass. There is no invisible force acting on it, only the structure of the universe guiding its motion. Einstein replaced the idea of action with the idea of relation. Matter and geometry are not separate entities. They are two sides of the same equation. When energy and mass change, the curvature of spacetime adjusts accordingly. When the curvature changes, matter responds with new motion. This self-referential system requires no external input. It sustains itself through perfect balance. Every motion in the cosmos, from the orbit of a moon to the expansion of the universe, unfolds as a consequence of that balance. And so, the question that opened our journey, why gravity never wastes energy, finds a deeper form here. It is not merely that gravity is efficient, it is that efficiency is built into the structure of space-time itself. The universe moves along paths of least action, conserving energy not as a rule imposed from outside, but as an identity woven into its being. Geometry does not tire because it cannot. It does not age because time itself flows within it. What we call gravity is the stillness of form beneath the ceaseless motion of matter. In the quiet elegance of Einstein's realization, the universe ceases to be a battlefield of forces and becomes a story of geometry. Every atom, every beam of light, every planet's curve through space is a line in that grand design. It is not motion that consumes, but motion that reveals. The planets orbit not because they are driven by power, but because the geometry of space-time demands that they do so. Each body follows its natural route, and in doing so, the cosmos sustains its own perfection. Picture the Earth circling the Sun for billions of years. Its path is precise, repeating with near-perfect fidelity through epochs longer than all human history combined. No hidden engine propels it. No secret mechanism corrects its drift. The geometry of space ensures that it always returns, always follows its appointed arc. This is why the word orbit is misleading. It implies motion around something, but the truth is simpler. The Earth moves straight ahead, forever falling through curved space, never needing energy to stay its course. In deep space, far from stars or planets, the same law holds. A lone rock floating between galaxies does not require fuel to drift. It moves along a straight line through space-time, an unbroken journey that could last longer than the universe itself. The absence of friction, of resistance, allows motion to persist indefinitely. This is the natural state of things. The universe does not require a motive force to sustain its unfolding. It requires only structure. The geometry of space-time provides that structure. Imagine a fabric so immense that it bends beneath the weight of stars, yet remains perfectly smooth. A massive body, such as the Sun, presses into this fabric, shaping the geometry around it. The planets, instead of being pulled, simply follow the curvature. This analogy of the marble and the bowl is incomplete, but evocative. The marble rolls because space itself is curved. Its inertia guides it along the contours created by mass. Energy conservation is maintained not through resistance, but through alignment with the natural shape of space-time. What makes this view astonishing is that it erases the need for gravity to act. There is no invisible rope connecting the Earth to the Sun, no continuous transmission of energy across the void. The curvature alone dictates the motion, and the motion perpetuates without expenditure. This understanding explains why the universe's great motions endure. It is not because energy is constantly replenished, but because none is required to maintain the geometry once established. In this sense, gravity is not a process. It is the form of all processes. Even light, which seems immune to weight, obeys this geometry. When a beam passes near a star, it bends. Not because the star pulls on it, but because the space the light travels through is curved. The shortest path through curved space appears as a bend to us, yet it is the straightest possible route within that geometry. This bending of light, observed during a solar eclipse in 1919, confirmed Einstein's vision and revealed that even the most massless of entities must follow spacetime's design. Light, the universe's messenger, is bound by geometry just as planets are. To the human mind, accustomed to cause and effect, this idea feels alien. We seek mechanisms, engines, and exchanges, but in spacetime, there are none. The rules of curvature alone define motion. It is as if the universe wrote a single, perfect equation and allowed everything to unfold from it. The conservation of energy, which seems so carefully maintained, is not an imposed law, but a natural consequence. Energy cannot be lost because there is no external frame in which it could vanish. All transformations occur within the same closed geometry. This makes gravity fundamentally different from all other interactions. The electromagnetic field can radiate, scattering energy as light. Nuclear forces can decay, releasing fragments into new configurations. These are processes that involve change, resistance, and loss. Gravity, by contrast, has no counterpart to friction. It can shape the flow of energy, but never absorb it. Space does not heat as planets move. It merely adjusts its curvature to maintain consistency. This property makes gravity the only truly dissipationless phenomenon known to physics. In this perfect economy, even the most chaotic events find equilibrium. When a comet swings close to the sun, its path bends sharply, flinging it back into the outer darkness. The change in direction looks violent, but no energy is lost to the curve. The potential energy gained during the comet's distant travel becomes kinetic as it rushes inward, then transforms back again as it escapes. Gravity facilitates the exchange without taxing the system. It provides the stage, but never pays a cost to host the performance. This harmony extends to the entire cosmos. On the largest scales, galaxies cluster into vast filaments, tracing patterns billions of light years long. Their distribution follows the curvature of space, set by the total energy of the universe. Even cosmic expansion obeys this geometry. The universe stretches, but the stretching itself does not dissipate energy in the ordinary sense. Instead, energy and curvature adjust together, maintaining a perfect balance. The cosmos evolves, but it never wastes. To live in such a universe is to exist within a masterpiece of conservation. Every falling stone, every orbiting world, every distant beam of light plays its part in the same silent equation. The idea that motion can persist without loss, that the cosmos can evolve without waste, challenges our instinct for entropy and decay. Yet it is precisely this that grants the universe its endurance. Gravity, by being geometry rather than force, transcends the cycle of consumption that defines all other interactions. Einstein's revolution did not merely replace Newton's equations with more accurate ones. It replaced the very idea of what motion means. Once we accept that gravity is geometry, the universe becomes not a machine that runs, but a shape that exists. Its beauty lies not in efficiency, but in inevitability. Every orbit, every curve of light, every fall of matter is written into the design. The universe does not need to sustain gravity because gravity is the structure of the universe itself. If one listens carefully to the logic of geometry, the universe begins to sound less like a machine and more like a thought. Motion is not powered, but permitted. A planet's endless revolution is not a contest against friction, but a silent expression of the curvature around it. Einstein's insight invites us to see that what we once called gravity is not an actor within the cosmos, but the rulebook by which the cosmos plays. The space that contains matter is not empty. It is active, sculpted by the very mass and energy it holds. And so, when the Earth moves around the Sun, it is not responding to a command. It is following the most honest line available to it, through a space-time gently curved by the Sun's presence. If you could stand far enough away and watch this unfolding in 4 dimensions, You would not see orbits as circles or ellipses. You would see elegant spirals curling through the fabric of space-time, each representing motion through both space and time. The planets trace these spirals naturally, without effort, as water follows the slope of a riverbed. There is no energy expenditure because the path requires none. The slope, once shaped by mass, determines the flow. The universe is a grand web of such flows, each motion contributing to and informed by the geometry around it. This is the meaning of Einstein's phrase that matter tells space-time how to curve and space-time tells matter how to move. There is no distinction between actor and stage. The two exist in continuous conversation, inseparable. When a star burns and loses mass, the curvature it creates softens slightly, and its planets adjust their orbits accordingly. When a dense body forms, space tightens around it, drawing nearby objects into new trajectories. Yet nowhere in this process does energy vanish. It is merely re-expressed as the geometry changes shape. This is also why the universe has no true center. In Newton's view, forces acted across distance, implying an anchor point somewhere. But in the geometry of general relativity, every point is local. Every region defines its own curvature. The universe folds upon itself, connecting all things through the smooth logic of space-time. There is no cosmic hub pulling at the edges, no hidden engine at the heart of existence. The curvature is everywhere, continuous and self-sustaining. This geometric self-consistency is what allows gravity to operate without decay. To understand this more deeply, imagine standing near a massive mountain. Light passing beside it bends ever so slightly, and time itself slows by a fraction so small it can barely be measured. You do not feel this change, yet it is there. The mountain's presence alters the rules of measurement, distances, durations, and directions within its immediate neighborhood. This is gravity at its most subtle. Not a pull, but a redefinition of what motion means. The mountain does not act upon the world. It changes the framework in which the world acts. That change persists as long as the mountain exists and disappears when it is gone, leaving no residue, no energy debt. When we look at galaxies rotating, their stars bound in a luminous spiral, we are witnessing geometry on a cosmic scale. Each star moves in a way that balances perfectly between its inertia and the curvature of space around the galactic center. The dance is graceful because it is governed by form, not force. The galaxy does not spend energy to keep its arms turning. The motion is simply the natural pattern within that curvature. Over billions of years, the geometry may evolve as stars are born and die, but the balance remains. Nothing is lost, only rearranged. This principle extends even to the expansion of the universe itself. As space grows, distant galaxies drift apart, not because something pushes them, but because the geometry of space-time evolves. The stretching is a property of the fabric, not a motion through it. When we measure the redshift of distant light, we are not witnessing energy dissipate into nothingness. We are seeing the transformation of wavelengths as space itself expands. Gravity, on these scales, is not the enemy of motion, but its sculptor. It defines how the universe grows while ensuring that energy and curvature remain in perfect correspondence. The efficiency of this system is staggering. The planets continue to orbit, the galaxies continue to spin, the universe continues to expand, all without any external supply of energy. This endurance is not a miracle, but a mathematical necessity. The equations of space-time are self-consistent. They contain within them the rule that energy and momentum must balance locally. The geometry cannot leak or fray because it has nowhere to leak to. Space and time are the entirety of the framework. Gravity never wastes energy because it has no outside to lose it to. In this light, the motion of the cosmos becomes the purest form of grace. The apple falling from a branch, the moon circling Earth, the slow drift of galaxies. Each is a reflection of geometry in motion. To exist in this universe is to inhabit a fabric that conserves by its very nature. Even decay, Even death, even collapse follow the same rule. Energy does not vanish, it changes address. The total story of the cosmos remains perfectly balanced, written in the language of curvature. This is the elegance that Einstein uncovered, a world where the silence of space is not emptiness but order, where gravity is not a struggle but a symphony. In this view, motion itself becomes effortless, because effort has no meaning where geometry alone rules. Every falling object, every orbiting world, every shifting star is part of a single unbroken narrative, a geometry that tells matter how to move, and in doing so, ensures that nothing is ever lost. In every machine built by human hands, motion demands a cost. A pendulum slows, a wheel grinds to stillness. Even light within glass scatters and weakens. Yet the planets move through their orbits for billions of years, as though powered by nothing. This defies every instinct we have about motion. Where is the fuel that drives them? Where is the engine that sustains their endless fall around the sun? The answer lies in the way gravity works, or rather, in the way it does not work at all. When we watch an apple drop from a tree, we say gravity pulls it down. The apple accelerates, gaining speed, gaining kinetic energy. But what gives it that energy? The answer is hidden in the balance between potential and motion. The apple begins high, filled with what we call gravitational potential energy. As it falls, that potential converts perfectly into kinetic energy, the energy of movement. When it strikes the ground, the energy is transformed again into sound, heat, and deformation. At no stage does gravity provide or consume energy. It only mediates the transformation. Imagine a hill. A rock perched upon its slope holds potential energy because of its position. When released, it rolls downward, gaining speed as it loses height. The hill itself does nothing. It does not expend effort to make the rock move. It simply provides a path that allows energy to convert from one form to another. In this way, gravity is not a force that acts upon things. It is the geometry of how energy rearranges itself. The rock, the hill, and the motion are parts of a single conversation that never requires an external voice. This insight becomes clearer when we examine celestial motion. The Earth orbits the Sun not because energy is constantly supplied, but because its potential and kinetic energies are in perfect exchange. At its closest approach, the planet moves fastest. At its farthest, it slows. The total energy, the sum of kinetic and potential, remains constant. Gravity orchestrates the rhythm of this dance without ever adding or subtracting from it. If space were frictionless and no other bodies interfered, the orbit could continue forever, a motion powered by the balance itself. This perfect equilibrium is what we mean when we say that gravity does not need fuel. It is not a motor, but a framework. It provides the shape in which energy can change form while the total remains untouched. In the human world, friction ensures that motion ends. The rubbing of surfaces converts organized motion into random vibrations, heat, the signature of energy lost to disorder. But space has no such friction. It offers no resistance. The Earth's orbit endures because there is nothing in the vacuum to take energy away. Even so, gravity appears powerful. It can bring stars together, collapse matter into black holes, and light the heavens with the energy of falling gas. Yet in each case, the energy comes from within the system itself. When gas spirals into a star, its potential energy decreases while its temperature rises. The heat and light that emerge are not gifts from gravity, but consequences of the rearrangement of existing energy. Gravity allows matter to fall into deeper wells of potential, releasing energy stored in configuration, but it never adds to the ledger. The universe remains balanced. This distinction between energy transfer and energy expenditure is crucial. Forces like electromagnetism can radiate, losing energy as waves of light. Friction converts motion into heat, scattering it into untraceable randomness. But gravity, as pure geometry, has no medium to lose energy into. When two stars orbit each other, they do so not through exchange, but through shared curvature. The system's total energy remains constant unless it emits gravitational waves, a phenomenon that occurs only in the most extreme cases. Even then, the energy is not destroyed. It moves outward as a distortion in spacetime itself, carrying the signature of motion without friction. Consider the orbit of a binary star system. Each star circles the other in a gravitational embrace that can last for billions of years. The stars accelerate constantly, yet they do not tire. The energy that drives their motion was set at the beginning of their dance. As long as nothing disrupts the symmetry, they will continue to orbit indefinitely. Gravity, in this sense, is like a stage upon which energy performs but never pays rent. The system conserves itself because geometry leaves no room for loss. When we apply this idea to the entire universe, a profound truth emerges. The cosmos is not a perpetual motion machine. It is a closed system where every transformation is balanced. Gravity's role is not to fuel but to shape. It defines how energy moves through space and how mass organizes itself. When galaxies form, when stars ignite, when planets coalesce from dust, all of it happens because geometry directs energy to flow along the easiest paths. Those paths require no external input. They are the universe's natural solution to its own equations. This understanding reframes the relationship between energy and motion. In our daily world, we think of energy as something consumed, spent, or wasted. But on the cosmic scale, energy is never lost. It is only exchanged. Gravity's perfection lies in its indifference. It neither gives nor takes. It simply allows. When a planet falls into orbit, it is like a pendulum finding its rhythm. The motion repeats endlessly because the system contains everything it needs to sustain itself. Gravity's efficiency is not a matter of conservation through restraint, but through inevitability. The idea that gravity does not need fuel also explains why its reach is infinite. A force that consumed energy would fade with distance, exhausting its source. But gravity's influence stretches across light years, binding galaxies and shaping the universe's large-scale structure. This reach requires no expenditure, because geometry extends without cost. Space-time curves according to mass, and that curvature defines how objects move. Near or far, the principle remains the same. The sun bends the space around it. Earth follows the curve. No energy crosses the gap because the gap itself is part of the curvature. If we look deeper, this efficiency reveals something almost spiritual in nature. The universe does not struggle to maintain itself. The stars do not burn for gravity's sake, nor do the planets labor to stay in their paths. Every motion we observe is the inevitable unfolding of form. Energy changes clothes, but the body beneath remains the same. Gravity's silence is the signature of its perfection. It requires nothing and wastes nothing. It is the ultimate expression of balance, the art of doing everything by doing nothing at all. The deeper one looks into gravity's nature, the more it resembles a conversation between possibility and inevitability. When we drop a stone into a pond, ripples spread outward, their energy fading into the stillness of water. When we drop a stone in space, it simply moves along a curved trajectory, silent and eternal. There is no surface to disturb, no medium to resist its motion. The stone follows a path of least action, the most direct route through space-time. The beauty of this lies in the fact that nothing external must sustain it. Motion endures because geometry dictates that it must. This principle defines the universe's quiet efficiency. Every motion we see is a rearrangement, not an expenditure. The falling apple, the orbiting planet, the collapsing star, each one conserves total energy while reshaping its form. Gravity is the stage upon which energy moves, not a participant in the play. The field itself, has no fatigue, no depletion. It does not push, pull, or strain. It simply curves. To see gravity as a force is to misunderstand its grace. It is not the actor, but the script. Even in the heart of violent events, this perfection holds. When a cloud of interstellar gas collapses into a star, potential energy converts into heat and light. The energy released comes entirely from the configuration of the gas, not from gravity itself. The geometry of spacetime allows the collapse to proceed smoothly, ensuring that the energy balances across the transformation. The brilliant light of the newborn star is a revelation of energy already present, made visible by the fall through curvature. Gravity facilitates this birth without spending a single quantum of its own. To illustrate this, imagine a ball rolling inside a smooth bowl. If you lift the ball and let it go, it will swing back and forth endlessly if there is no friction. The total energy remains constant. Potential becomes kinetic, and then potential again. Gravity in the universe works like that frictionless bowl. Planets, stars, and galaxies move within spacetime's contours, exchanging energy between motion and position. But the total never changes. The bowl itself does not tire or lose form, because it is not a physical surface, but a description of geometry. That is why the cosmic dance can last forever. Human intuition resists this idea because in our world, everything ages. Friction and resistance are constants of life, but those phenomena belong to matter, not to space-time. They arise from microscopic interactions, atoms jostling, fields interfering, energy spreading into disordered heat. Gravity, however, is not a field living inside space. It is space itself. There is no underlying medium to dissipate energy into. When something moves under gravity, the motion does not wear the geometry down. It follows the lines of curvature as a river follows its bed, always and effortlessly. This understanding also clarifies why gravitational energy is so difficult to define precisely. In electromagnetism or mechanics, energy exists within a field or a moving mass. But in general relativity, energy is distributed through the curvature itself. There is no single place where one can point and say, "Here lies the energy of gravity." It is everywhere and nowhere, a relational property, not a substance. That is why gravity never wastes energy. It has no distinct reservoir from which to draw or into which it could leak. The geometry simply is, and energy within it moves in perfect harmony. If we extend this idea across the cosmos, the same balance holds at every scale. The galaxies that form vast clusters and filaments are not consuming energy to maintain their shape. They are following the natural contours of the universe's curvature. The matter within them flows where space-time directs, pooling into stars and planets like rain gathering in valleys. This motion requires no power source, no external maintenance. Once curvature exists, it ensures continuity. The great structures of the cosmos are the inevitable consequence of initial conditions, not the result of ongoing expenditure. Even the act of falling, so dramatic to us, is an illusion of perspective. To the falling object, there is no sensation of force, no feeling of being pulled. It moves freely along a geodesic, the straightest possible path in curved spacetime. This is why astronauts in orbit experience weightlessness. They are not escaping gravity, but living within its purest expression, continuous free fall. Their motion is effortless, because gravity demands no effort from them. The curve of spacetime carries them exactly as it carries planets and light. This view transforms the very concept of power. When we speak of engines or fuels, we imagine effort overcoming resistance. But in the geometry of the cosmos, there is no resistance to overcome. Motion arises from alignment, not exertion. The universe does not work, it unfolds. Its perfection lies not in consumption, but in coherence. The sun does not fuel Earth's orbit, nor does the galaxy expend energy to keep its stars bound. Each follows the simplest route permitted by Spacetime's shape. This is why the night sky looks unchanging over millions of years. The cosmic machine does not burn, it glides. And yet, this effortless nature hides immense energy. The potential stored within curved spacetime can be vast. When matter collapses into a black hole, the energy released can outshine entire galaxies. But even here, gravity adds nothing. It merely permits energy to flow from configuration to radiation, from order to new order. The black hole's formation marks a change in geometry, not an expenditure. The energy emitted was always part of the system, waiting for the right conditions to manifest. The balance is perfect. Nothing is wasted. Nothing is spent. To see gravity this way is to glimpse the deep economy of the universe. Everything that moves does so because it must, not because something drives it. Every orbit, every fall, every pulse of light across the cosmos reflects the same principle of conservation. Gravity needs no fuel because it is not a process. It is the structure within which all processes occur. Its silence is not emptiness, but equilibrium. Its stillness is not absence, but completion. The perfection of gravity's design becomes most evident when we look beyond the scale of stars and planets into the architecture of the cosmos itself. The great clusters of galaxies that form the skeleton of the universe do not drift apart through exhaustion, nor do they collapse from any loss of energy. They move in patterns set long ago, obeying the same laws that guide the fall of an apple. From the smallest grain of dust to the vast web of galaxies, every motion is a consequence of balance, not expenditure. The universe sustains itself because gravity requires no sustenance. To understand why, imagine a pendulum swinging in a vacuum. Without air to resist it, the pendulum would swing forever, converting potential to kinetic energy and back again with flawless precision. Gravity is like that vacuum on the grandest possible scale. It provides no friction, no mechanism for loss. A planet circling a star, a moon circling a planet, all obey the same geometry. Their kinetic energy increases and decreases in response to position, but the total remains constant. The exchange is eternal. The cosmos has found a way to move without ever tiring. This conservation does not mean the universe is static. On the contrary, gravity allows change while keeping the total energy perfectly balanced. Stars are born and die, galaxies collide and merge. Yet in each act of cosmic transformation, energy only shifts form. The brilliance of a supernova is energy released from the collapse of matter, not energy supplied by gravity. The structure of spacetime accommodates every change, ensuring that nothing is lost to waste. The universe remains whole, no matter how turbulent its contents become. There is something deeply philosophical in this realization. It suggests that the universe's apparent motion is not a sign of chaos, but of self-organization. Gravity is the principle that ensures coherence in the midst of transformation. It gathers matter into stars, planets, and galaxies, then allows them to evolve and dissolve without any imbalance in the grand total. Every collapse, every orbit, every wave is part of a single accounting so exact that even eternity cannot alter it. This is why gravity never seems to fade. It is not a current flowing through space, but the definition of space itself. At times, gravity reveals this balance through phenomena so subtle that they border on paradox. For example, in the orbit of a binary star system, one might expect the constant acceleration of each body to require work, to consume some source of energy. Yet the stars continue their dance for eons, their paths almost unchanging. No energy is spent, because none is required to maintain the curve of motion. The system's total energy, a blend of potential and kinetic, remains perfectly conserved. Even when the stars radiate light, the energy comes from their own nuclear reactions, not from the act of orbiting itself. Gravity merely shapes the choreography. Only in the most extreme circumstances, such as the merger of black holes, does gravity appear to release energy in the form of gravitational waves. These ripples in space-time travel outward at the speed of light, carrying information about the event. Yet even here, the energy is not created by gravity. It is drawn from the motion of the bodies involved. The geometry itself adjusts seamlessly, ensuring that the total remains constant. The wave is not a loss, but a redistribution, a transfer from localized motion to the curvature of space-time as a whole. Even in its most dynamic form, gravity remains perfectly efficient. This realization leads to a profound truth. Gravity does not operate within the universe. It is the universe's operating principle. Every other force acts through particles or fields that inhabit space. Gravity defines the space in which those interactions occur. It is not transmitted, absorbed, or dissipated. It is simply the rule of how everything relates. That is why it cannot waste energy. There is no elsewhere for energy to escape to, no external frame where loss could be measured. All exchanges take place within the single, self-contained geometry of space-time. We can see this most clearly when we step outside our small corner of existence and imagine the universe as a whole. The total energy of the cosmos, when described in the language of general relativity, is precisely zero. The positive energy of matter and radiation is balanced by the negative potential energy of gravity. This perfect symmetry means that the universe does not need an external power source to exist or to evolve. Its expansion, its structure, its motion, all are contained within a balance so exact that the net cost of creation is nothing. The cosmos, in its vastness, is a perfect equation. If one accepts this, then gravity's silence becomes not a mystery, but an inevitability. It does not waste energy because it has no energy to waste. It is the expression of the universe's capacity to conserve itself absolutely. Every system, from the orbit of an electron in a gravitational field to the dance of galaxy clusters, obeys this same law. When viewed through this lens, the cosmos becomes the ultimate perpetual motion, not because it violates physics, but because it is physics in its purest form. Motion continues without end, not fueled by something external, but sustained by the geometry of being. The universe, then, is a self-writing story. Gravity provides the grammar, energy provides the words, and matter gives the plot. Together they create a narrative that unfolds without effort, each chapter written by the balance of what came before. This is why gravity feels eternal and why its influence never fades. It does not pull, push, or burn. It simply is. The shape of time, the memory of energy, the enduring logic of existence. Every orbit, every fall, every curve of light is a line in that story. Proof that the cosmos requires no fuel to remain alive. In the deep quiet of the cosmos, there are moments when space itself trembles, not from sound or motion through air, for there is no air to carry a vibration, but from the geometry of reality shifting under its own weight. These are gravitational waves, ripples in space-time that travel across the universe at the speed of light. They are the faint echoes of cosmic cataclysms, the final sighs of colliding black holes, the whispers of stars collapsing into darkness. When the Laser Interferometer Gravitational Wave Observatory first detected such a ripple in the year 2015, humanity heard, for the first time, the sound of space-time ringing like a vast, invisible bell. These waves are unlike any other form of energy we know. A sound wave moves through air, disturbing molecules. A light wave moves through electromagnetic fields, transferring photons. A gravitational wave moves through nothing. It does not need a medium because it is the medium. Space itself stretches and squeezes as the wave passes, changing the distance between objects without them ever moving of their own accord. Two mirrors placed kilometers apart will seem to drift closer and farther in rhythm, yet they are merely following the temporary shape of the universe as it oscillates around them. The energy is not carried by particles or fields. It is pure geometry in motion. To understand how such a phenomenon can exist, we must remember that gravity is not a force acting within space, but the structure of space itself. When two massive bodies such as black holes spiral around each other, their immense masses warp spacetime. The curvature shifts dynamically as they move, sending ripples outward. These ripples are the propagation of change in the geometry, the rearrangement of spacetime's own fabric. The astonishing part is that this process still conserves energy perfectly. The energy radiated away in the wave does not vanish into heat or noise. It travels intact, a pure expression of motion through curvature. When the black holes in that first detection collided, they released an amount of energy equivalent to several suns converted entirely into gravitational waves. Yet nothing was lost to friction or resistance. The event did not heat any medium, for there was none. It did not scatter, for spacetime offers no obstacles. The wave traveled for more than 1 billion years before reaching Earth, crossing galaxies, clusters, and voids. And when it arrived, its form was almost unchanged. This endurance reveals gravity's most extraordinary property. Even when it radiates, it does so without dissipation. Unlike light, which can be absorbed or scattered by dust and matter, a gravitational wave passes through everything. It interacts so weakly that it can traverse the entire observable universe with almost no loss of intensity. When we detect such a wave, we are not observing a secondary effect or a reflection. We are touching the very tremor that left a distant event eons ago. In that moment, space-time itself connects us directly to the source, unbroken and uncorrupted. No other signal in the cosmos can travel so purely. Gravity, even in its most dynamic form, refuses to waste what it carries. This purity is a direct consequence of gravity's geometric nature. Because it has no medium, there is nothing to resist its motion. The equations that describe spacetime, Einstein's field equations, ensure that these waves propagate freely, obeying the same conservation laws that govern all motion. The wavefront moves at the speed of light because that is the speed at which information can flow through geometry. Yet the geometry itself remains whole. The energy transferred by the wave does not diminish the integrity of spacetime. It merely redistributes curvature, maintaining the perfect balance of total energy. When we speak of gravitational waves carrying energy, it is important to recognize what kind of energy this is. It is not energy in the traditional sense, not heat, not radiation, not momentum in a medium. It is energy expressed as a change in geometry. The curvature of spacetime near the colliding black holes decreases slightly as part of it propagates outward in wave form. That energy continues through the cosmos as oscillations in the metric of space and time. Wherever it travels, it does not degrade. There are no atoms to absorb it, no dust to dim it. The universe merely flexes and then relaxes, unchanged except for the echo that has passed through. Even the most sensitive instruments on Earth can barely detect such waves. When one passes, it changes the length of a 4-kilometer tunnel by less than the width of a proton. Yet that minuscule vibration carries more energy than any explosion humankind has ever produced. The paradox is striking. Immense power, infinite subtlety. This is the hallmark of gravity. It is the most patient force, manifesting in vast scales of energy and time, while leaving the smallest possible trace upon the local world. These discoveries have shown us that gravity, though seemingly static, can sing. Its music is the vibration of spacetime itself, a song so low and pure that only the most precise instruments can hear it. Each note tells a story of black holes merging, of neutron stars colliding, of the violent shaping of the cosmos. Yet the melody never distorts. It carries truth unaltered across billions of years. The fact that we can still detect these waves in their original form is proof of the dissipationless perfection of gravity. It is the only known process in nature that can transmit energy across such unimaginable distances without loss. The existence of gravitational waves completes the picture of gravity's dual nature. It can be both utterly still and profoundly dynamic. It can hold planets in eternal orbit and carry the memory of a star's death to the edge of time. But in both roles, it remains faithful to the same principle: conservation through geometry. When space rings, it does not decay. It vibrates and returns to silence, leaving no residue, no heat, no ash. The universe remembers the motion, but not the cost. The discovery of gravitational waves revealed that even silence can carry a story. Before that moment, we believed we could only see the universe, never truly hear it. Light, for all its brilliance, shows us only the luminous fraction of what happens. It cannot pass through the dense shrouds of dust where stars are born, nor can it reveal the heart of black holes where matter disappears beyond view. But gravitational waves move through everything, indifferent to barriers. They carry the memory of motion itself, the pure geometry of events long vanished. When space vibrates, it is the universe whispering its own autobiography. Imagine two black holes locked in an orbit tighter than the circumference of the Sun. For millions of years, they circle each other, spiraling slowly inward. Every revolution sends a tiny ripple through space-time, a signal that travels outward in perfect symmetry. Each orbit drains a minute fraction of the system's total energy, not as waste, but as structured curvature radiating away. When they finally merge, the collision releases a surge of gravitational waves, their frequencies rising like the final note of a cosmic crescendo. The fabric of the universe flexes, then returns to calm. The energy is gone from that region, but not destroyed. It now exists as motion in the geometry itself, continuing forever outward. Unlike sound or light, which fade as they spread, gravitational waves retain their shape because space-time offers no friction. There are no particles to scatter them, no medium to slow them down. Even across billions of light years, they arrive as perfect echoes of their origin. The wave that trembled through Earth in 2015 had begun its journey when multicellular life was just emerging in our oceans. For over 1 billion years, it crossed the universe unaltered. When it finally brushed past our planet, it stretched space by less than the width of an atomic nucleus. Yet that was enough for our instruments to feel its passing. This endurance reveals something profound about the nature of energy itself. In every physical system, energy conservation holds, yet energy almost always changes form, degrading into less useful configurations. Heat spreads, light scatters, momentum disperses. But gravitational radiation never becomes disordered. It does not dissolve into noise because there is no environment for noise to exist in. It is the purest transmission possible, a wave made of nothing but change. This means that gravity can carry energy across the cosmos without ever producing entropy. It is, in the truest sense, dissipationless. The equations describing this are elegant in their precision. They show that when mass and energy accelerate through space-time, the resulting curvature adjustment moves outward at the speed of light. The wave's amplitude decreases with distance, but not because of loss. It diminishes only because its energy is spread over a larger area. The total remains the same, distributed perfectly across the expanding front. No heat is created. No work is done against resistance. The propagation is as flawless as geometry allows. Gravity, even when it radiates, preserves balance absolutely. What makes this even more astonishing is how little gravity interacts with itself. Electromagnetic waves can collide and interfere, creating new frequencies or dissipating energy. Gravitational waves pass through each other, almost unaffected, as though the universe prefers not to disturb its own silence. This nonlinearity, the fact that space-time curvature does not easily tangle with itself, ensures that even the most complex gravitational events leave behind clean, undistorted signals. The cosmos can be filled with countless overlapping ripples, and yet they remain distinguishable, each wave preserving its integrity from origin to infinity. When we think about what this means, a picture begins to emerge of a universe that is not just efficient, but profoundly self-consistent. Gravity does not need to spend energy because it already encompasses every form of energy within its geometry. When something moves, when something collapses, when something radiates, the total curvature simply adjusts to accommodate the change. Gravitational waves are proof that this self-consistency extends even to motion itself. They are the universe's way of balancing its own equations. There is a subtle beauty in the idea that even catastrophe can be clean. The merging of black holes is among the most violent events imaginable, yet the process produces no debris, no heat, no chaos. The energy released is not destruction, but translation, the conversion of mass into curvature, form into vibration. When the wave passes, space returns to stillness, unchanged, except for the gentle redistribution of energy across its vastness. Nothing is wasted, and nothing is broken. The event is both an ending and a continuation, a perfect cycle of motion within geometry. This is why physicists often describe gravitational waves as the most faithful messengers in the universe. They do not merely describe events, they are the events. A ripple in spacetime is the direct extension of what caused it, still connected to its source across unimaginable distances. When we detect one, we are not receiving information in the ordinary sense. We're experiencing the universe itself shifting minutely beneath our feet, as though time were remembering what happened elsewhere. The cosmos communicates with us through its own structure. To think of space as capable of ringing is to accept that it has tension, elasticity, and form. But unlike any material, this form never degrades. A wave may travel forever without losing coherence because space-time is both the path and the traveler. It does not fatigue, and it does not warm with motion. It is the perfect medium because it is not a medium at all. This is the deepest expression of gravity's dissipationless nature. It transmits energy not through interaction, but through being. The universe moves, but it never labors. The waves that ripple through space-time remind us that even the most serene silence can carry infinite motion. When space vibrates, it reveals its hidden strength. That geometry alone can hold, carry, and restore energy without ever wasting it. The collisions that birth these waves are temporary, but the waves themselves endure, timeless as the structure that supports them. Gravity, it seems, does not only shape the universe, it also allows the universe to remember itself without ever forgetting balance. When a gravitational wave passes through, it leaves nothing behind except the faintest rearrangement of distance. Two mirrors move closer and then farther apart by an amount so small it defies imagination. The geometry of the universe flexes, then returns to rest. There is no trace, no scar, no loss. This is what makes gravitational waves so extraordinary. They are both real and intangible, powerful and delicate. They can carry more energy than 1,000,000 suns, yet they pass through everything, as though space itself were made of glass. These ripples are born in violence, but travel with serenity. They are the final product of collisions so immense that time and space twist into knots, yet the waves themselves are perfectly smooth. Every crest and trough is a precise record of motion, of the dance between mass and curvature. Each one tells a story that unfolds without distortion. When we detect them, we are not hearing an echo. We are feeling the same rhythm that pulsed through space-time at its origin. The wave that touches our detectors is part of the same structure that once surrounded the merging black holes. Nothing has been lost along the way. This persistence speaks to gravity's flawless efficiency. In most forms of energy transfer, information degrades, sound fades, light scatters, particles collide and convert order into heat. But a gravitational wave is not a vibration through matter. It is the rearrangement of space-time itself. Because nothing lies outside space-time, there is nowhere for its energy to dissipate. It moves eternally through the structure that defines motion. Even as the universe expands, the wave stretches smoothly, maintaining perfect fidelity. The energy thins only because the wavefront grows, not because any part of it is destroyed. The purity of these waves makes them more than scientific curiosities. They are cosmic messengers from epochs beyond sight. Light can show us the surface of events, but gravity reveals the structure underneath. Through gravitational waves, we have glimpsed the invisible. Black holes colliding, neutron stars merging, entire galaxies quivering under the weight of their own geometry. These are not visual phenomena. They are events of pure form, pure curvature, the kind of motions that could exist even in a universe made only of space and time. To study them is to listen to the universe thinking aloud. When we trace a gravitational wave backward, we find the geometry of its source written into its pattern. The frequency tells us the masses of the bodies that created it. The shape of the signal reveals their spin, their distance, even the angle at which they collided. Yet all this information arrives encoded in motion alone. No photons, no particles, no fields, only space-time shifting minutely in rhythm. The fact that such precision can survive across billions of light-years shows that gravity's medium cannot forget. It carries the memory of the universe without ever erasing a line. This enduring perfection raises an extraordinary implication. If space can ripple, and if those ripples carry energy, then space-time is not merely the stage upon which the cosmos acts. It is an active participant in the play. When we speak of gravitational waves, we are speaking of the universe's ability to feel and respond to motion. Yet even in this responsiveness, there is no loss. The waves are a re-expression of geometry, not an expenditure of it. Space moves and then returns to rest, the energy redistributed but not diminished. In a sense, gravitational waves prove that the universe is capable of communication without consumption. It can broadcast its most dramatic events across the cosmos without paying a price. The fabric of reality vibrates, but those vibrations do not exhaust it. The wave is both messenger and message, the act and its own record. It carries energy flawlessly because it is energy in geometric form. When it passes, the universe remains exactly as it was, balanced to the last fraction. And so, when we think of gravity as dissipationless, it is not a poetic exaggeration. It is a literal truth. From the slow orbits of planets to the roaring collisions of black holes, gravity wastes nothing. It is the only phenomenon in nature that can move energy across eternity without leaving behind disorder. The universe itself rings like a perfect instrument, every vibration a note that fades without decay, every wave a reminder that space and time are one continuous, unbroken whole. The silence that follows each cosmic chord is not emptiness. It is balance restored. Space relaxes, time smooths, and the universe returns to its quiet equilibrium, waiting for the next great motion to send a new ripple through its depths. Gravity, through its waves, has shown us that energy can travel forever and never die, that the universe itself is the keeper of perfect symmetry. The universe has always known how to conserve itself. Every movement, every orbit, every collapse is part of a seamless accounting where nothing is lost and nothing is wasted. Gravity stands at the heart of this perfection. It does not struggle against resistance or consume what it moves. It works because the universe itself is built to keep its balance. To understand this is to see that the dissipationless nature of gravity is not an accident of physics. It is a consequence of design. Einstein's equations tell us that energy and momentum are conserved locally in every region of space-time. This is not a rule imposed upon the universe from the outside. It is a property of the geometry itself. The field equations that describe gravity are written in a language of symmetry. They ensure that curvature and energy always match, that change in one means equal change in the other. Because space-time is the total system, the frame, the content, and the context, there is no external reservoir where energy could vanish. The balance is built into existence itself. This makes gravity unique among all the forces. Electromagnetism can dissipate energy as heat or light when it interacts with matter. The strong and weak nuclear forces operate in the fleeting chaos of subatomic reactions, always producing byproducts and waste. Gravity alone remains untainted. It acts universally, but never interferes destructively. Its field lines are not absorbed, deflected, or tangled. Space curves smoothly, continuously, and self-consistently. There are no cracks, no leaks, no rough edges through which energy could escape. Imagine space-time as an immense, self-sustaining fabric. When a mass appears, the fabric adjusts to accommodate it. The adjustment costs nothing because it is part of the fabric's definition. There is no before and after in the way a human mind thinks of cost and effort. The geometry simply becomes what it must be. If the mass moves, the curvature shifts accordingly, transmitting information outward as gravitational waves. Even then, no friction slows it down, no field resists. The motion continues in perfect accord with conservation. The design itself forbids waste. One of the profound reasons gravity remains dissipationless lies in its weakness. The gravitational constant is so small that it takes astronomical quantities of mass to produce noticeable curvature. Because it couples so weakly, gravity interacts minimally with other forms of energy. This weakness ensures that gravitational waves travel across the universe almost untouched. The same property that makes gravity feeble in the laboratory makes it flawless on cosmic scales. The geometry is nearly immune to interference. It is the closest thing to perfection nature allows. Consider how a magnetic field behaves. When it passes through a conductor, it induces a current. The current, in turn, generates heat as electrons collide within the material. Energy is lost to friction at the atomic level, but gravity has no conductor, no charge carriers, no particles to rub against. It exists as pure curvature, and curvature cannot collide with itself. Even when multiple gravitational waves cross paths, they pass through each other like overlapping shadows, unchanged and undiminished. This absence of self-interaction is not weakness, it is purity. The conservation built into gravity's equations ensures that energy moves only in closed exchanges. When a star falls inward under its own weight, the potential energy that vanishes is reborn as heat and radiation. When two planets circle one another, their kinetic and potential energies trade endlessly without loss. The curvature of space-time acts as the ledger that tracks every transaction. Nothing is unaccounted for, and the total never shifts. The dissipationless nature of gravity is the mathematical reflection of perfect bookkeeping. We can trace this perfection back to the symmetries of space-time itself. Noether's theorem, one of the most elegant ideas in physics, states that every symmetry corresponds to a conserved quantity. Because the laws of physics are the same at every point in space, momentum is conserved. Because they are the same at every moment in time, energy is conserved. Gravity, being the geometry that defines space and time, embodies these symmetries entirely. It cannot break them because it is them. In this sense, gravity's dissipationless design is not a feature added to the universe. It is the universe. Even in the most extreme environments, such as near the event horizon of a black hole, this principle holds. The immense curvature does not tear the fabric of space-time. It merely folds it more tightly. The surface area of the horizon records information about everything that falls within, preserving it in the most fundamental way. The system adjusts but never loses coherence. Space stretches, time slows, yet the total energy remains constant. What seems like consumption or loss from one perspective is, in the language of geometry, simply reconfiguration. This idea reshapes how we think about stability itself. The planets that circle their suns, the galaxies that spin in quiet majesty, the clusters that drift through cosmic time, all persist not because they resist decay, but because they inhabit a framework incapable of wasting energy. The universe endures because its architecture enforces endurance. Gravity's role is not to oppose entropy, but to give structure to its flow. Even as disorder increases within matter, the geometry that hosts it remains unbroken. The dissipationless nature of gravity is thus both physical and philosophical. It is physical because it arises from the mathematical laws of space-time. It is philosophical because it reveals the elegance of a universe that conserves not only energy, but meaning. Every movement, every vibration, every orbit contributes to the same eternal balance. The stars that die enrich the medium that births new stars. The galaxies that merge form larger structures that continue to rotate. Nothing ends in loss, only in transformation. The universe's refusal to waste energy is not a coincidence of physics, but the inevitable outcome of its own design. Gravity, as the geometry of space-time, guarantees that every transformation preserves balance. Even in the vast emptiness between galaxies, this design holds perfectly. There are no eddies, no decays, no currents of loss. The cosmic stage sustains itself with absolute precision, guided by equations that know how to conserve. Every orbit, every fall, every ripple in space-time fulfills this silent command. Maintain symmetry, and nothing will be lost. If one could step outside time and watch the universe unfold, the constancy of this principle would be breathtaking. From the first flicker of light after the great expansion to the last cooling embers of distant stars, energy only changes shape. A cloud of hydrogen becomes a star. The star becomes radiation and dust. The dust becomes planets, and those planets one day dissolve back into stardust. Gravity directs every exchange with perfect efficiency. It never interrupts the cycle. It only defines the curves along which energy travels. The pattern is as endless as time itself, written in the metric of space. To appreciate how flawless this mechanism is, imagine removing gravity from the universe for a moment. The laws of motion would still exist, but they would have no anchor. Matter would drift without pattern, and energy would disperse irreversibly into chaos. The universe would still obey conservation, but it would lack coherence. Gravity provides that coherence. It ties energy to form, motion to memory, existence to continuity. The dissipationless nature of gravity is the reason the cosmos possesses structure at all. It keeps the universe from dissolving into a meaningless fog of expansion. Even the concept of a gravitational field losing energy is misleading. In classical terms, a field can radiate away energy, yet what radiates in gravity is not a field distinct from space, but space itself. When a gravitational wave moves, the curvature changes, but the total geometry remains consistent. Energy simply relocates within the fabric, adjusting to maintain balance. It is as though the universe breathes, exhaling in one region and inhaling in another, always keeping the total volume unchanged. This is the essence of a dissipationless design: motion without loss, change without decay. Every other physical process seems noisy compared to this. A wire carrying current heats with resistance. A spinning wheel slows as friction turns motion into warmth. Light diffuses when it meets dust. These forms of dissipation are the signature of imperfection. They occur whenever energy encounters irregularity. Gravity, however, is flawless because it has no medium, no irregularities, no surface to rub against. Its purity comes from its universality. Space-time does not exist within something else. It is the something. It cannot lose energy because it has nowhere to lose it to. The more one studies Einstein's equations, the more this perfection reveals itself. The stress-energy tensor, which describes the distribution of energy and momentum, is always paired with curvature through an exact relationship. The divergence of this tensor is zero, a mathematical way of saying that energy cannot vanish. This is not an assumption, but a necessity. The geometry of space-time demands it. Gravity therefore inherits a kind of built-in immortality. It preserves energy not by effort, but by definition. The universe does not choose to conserve. It cannot do otherwise. This design extends into every scale. Within galaxies, the balance between rotation and gravity's pull prevents collapse and dispersal alike. Within planetary systems, orbital motion continues because there is no friction in space to sap momentum. Even the orbits of binary pulsars, slowly decaying through gravitational radiation, lose energy only through geometry itself, not through resistance. The wave that carries that energy remains pristine, undiminished by travel. Every loss is a transfer, every transfer a perfect preservation. The universe remains a closed loop of eternal balance. In this sense, gravity is not just dissipationless, it is self-repairing. If the curvature of space is disturbed, it responds by adjusting instantly, restoring equilibrium. Distortions travel as waves that leave the underlying geometry unbroken. No cracks form, no tears remain. The resilience of spacetime comes from its mathematical completeness. The equations that define it do not allow discontinuities. This is why gravity can carry energy without weakening. It is the only system in which motion and structure are the same thing. To exist within such a system is to live inside a masterpiece of conservation. Every atom, every photon, every grain of dust participates in this vast economy of geometry. The shapes we see in the night sky, the spirals of galaxies, the arcs of planetary orbits, the tides that rise and fall, are expressions of the same unbroken rule. The universe does not bleed energy into oblivion. It recycles it with perfect precision. Gravity is the architect of that recycling, the eternal mechanism that turns transformation into continuity. The more deeply we understand this, the more humbling it becomes. There is no waste in the cosmos. There are only exchanges between motion and form, between curvature and time. Gravity's dissipationless nature reveals the underlying logic of reality itself. The universe is not fighting decay, it is dancing with it, ensuring that every step, every note, every vibration contributes to a perfect, timeless equilibrium. The idea that gravity is dissipationless invites a new way to see the universe, not as a place where things happen, but as a pattern that maintains itself. Every event, from the orbit of a moon to the collapse of a star, unfolds within a structure that never wastes motion. The same geometry that bends light around galaxies also preserves energy within the smallest fluctuations of space. This is why the cosmos can evolve endlessly without exhausting itself. Gravity ensures that even as matter changes, the total harmony remains unbroken. Imagine the deep void between galaxies, where space stretches so far that one could travel for billions of years without finding a single atom. Even there, gravity rules with invisible precision. Its equations continue to hold. Its geometry remains perfect. If two galaxies drift toward each other, their paths are guided by curves of space-time that existed long before they met. When they collide, the violence we see, the bursting of stars, the distortion of shape, is only the visible expression of a deeper conservation. Energy is redistributed across form and motion, but not a single fragment is lost. The geometry adjusts, and the balance persists. This is the profound secret of gravity's design. It allows transformation without decay. When matter falls inward, potential energy converts into kinetic. When stars burn, mass converts into light. When galaxies merge, motion converts into curvature. Each process is a reshaping, never a destruction. Even the energy radiated away in gravitational waves does not disappear. It remains part of the universal total, encoded in the undulations of space-time that travel endlessly outward. The design forbids waste because the universe itself is the system. There is no outside where energy could vanish. If one could read the universe as a vast equation, gravity would be its syntax, the structure that keeps meaning intact. Every particle and field obeys the rules written by curvature. The conservation of energy, the constancy of momentum, the persistence of motion, all are expressions of the same grammar. And because the grammar itself never changes, the story remains coherent no matter how complex the plot becomes. Stars are born, galaxies collide, black holes form and evaporate, yet the total narrative always balances line for line. gravity is the editor that ensures nothing is wasted, not even a pause. This self-sustaining order is what allows the universe to be both dynamic and eternal. Change does not mean decay. Motion does not require replenishment. The planets orbit because geometry tells them to, not because energy is spent to keep them moving. The expansion of the universe occurs because space-time itself evolves, not because something pushes it outward. Gravity defines this evolution as a closed process. It bends, it flexes, it vibrates, but it never bleeds energy away. The cosmos moves like a pendulum that never slows, because the pendulum and its space are one. At the heart of this lies a remarkable truth. Space-time is not a passive stage. It is an active participant in every event. The presence of energy shapes it, and in return, it governs how energy moves. This reciprocity means that the system can never fall out of balance. Any distortion in one part of space-time is corrected by the curvature around it. The equations of general relativity encode this feedback perfectly. What we perceive as the steadiness of orbits or the endurance of cosmic motion is simply the natural consequence of this feedback loop. Gravity is not just dissipationless, it is self-regulating. Even on the scale of the entire universe, the same principle applies. The energy of matter and radiation is positive, while the energy of gravity itself is negative. Together, they sum to zero. This is not poetic symmetry, but physical law. It means that the universe could emerge from a state of nothingness without violating conservation. The creation of space and time is not an act of expenditure, but of balance. Gravity makes this possible by providing the negative counterpart to every form of positive energy. In this sense, the dissipationless nature of gravity is not merely a feature of existence. It is the reason existence can begin at all. This perfect design extends even to the cosmic future. As stars burn out and galaxies drift apart, gravity continues to weave the fabric of geometry without loss. Even black holes, those great consumers of matter, obey the same conservation. The mass that falls in becomes part of the horizon's curvature. The information it carries is preserved on the surface, encoded in the most fundamental way. When the black hole eventually evaporates through quantum processes, the energy returns to the universe, the balance restored. There is no true disappearance, only transformation within the framework. To recognize this is to glimpse the deeper nature of perfection in the cosmos. Gravity's dissipationless design is not mechanical efficiency. It is existential coherence. It is the reason the universe endures, the reason structure persists, the reason motion continues. Everything that exists does so within a geometry that guarantees conservation. The stars may fade, but the equations remain. The curvature may stretch, but the total stays constant. Gravity is not simply a feature of the universe. It is the pattern that makes eternity possible. In this view, even the silence of space becomes meaningful. The absence of friction, the stillness between stars, the quiet persistence of motion, all are signs of an underlying intelligence in nature's design. The universe does not waste because it cannot. Its laws are written too precisely for loss to exist. The dissipationless perfection of gravity is the final proof that the cosmos is not a machine running down, but a balance unfolding. A design so complete that even time cannot erode it. Across the great span of the cosmos, gravity seems both omnipresent and almost imperceptible. It holds galaxies together, bends the paths of stars, sculpts the very shape of space and time, yet between two small objects it is feeble beyond comprehension. The attraction between a pair of paperclips on a desk is so weak that the smallest static charge can overpower it completely. The gravitational constant, that mysterious letter G, is unimaginably small. In the language of numbers, it is about 10 to the power of -11 Newton-meter squared per kilogram squared, a figure so tiny that it is nearly lost in the immensity of calculation. And yet this delicate thread, invisible and almost silent, binds the entire universe. How can something so weak be the architect of everything large enough to matter? The answer lies in the paradox of strength itself. Gravity's weakness is the reason it never dissipates, the reason it endures. Unlike the electromagnetic force, which can be both attractive and repulsive, gravity only attracts. The electric forces between positive and negative charges cancel over distance, leaving no net effect on the cosmic scale. But gravity, always pulling, always gathering, accumulates. Every grain of matter contributes, every atom adds to the total. Over small distances, the strength of electromagnetic forces overwhelms gravity by 38 orders of magnitude. Yet on the scale of stars and galaxies, all charges neutralize each other, leaving only gravity to rule. Its weakness on the small scale becomes its dominance on the grandest one. When two galaxies approach each other, gravity acts not as a sudden force, but as a patient sculptor. It draws them together over billions of years, allowing time for each to rotate, to form stars, to evolve. This slowness is not inefficiency, it is precision. Gravity's weakness ensures that cosmic motion unfolds at a pace that preserves stability. If gravity were as strong as electromagnetism, stars would collapse instantly, planets could not form, and matter would clump into chaos. The universe would have burned itself out before it began. Instead, gravity's near invisibility gives the cosmos the gift of endurance. It builds slowly, allowing complexity to arise. Weakness becomes the foundation of longevity. Because gravity interacts so faintly, it also avoids the traps of dissipation that plague every other force. When a magnetic field fluctuates in a conductor, it creates currents that lose energy as heat. When light travels through matter, it scatters and absorbs, bleeding energy into lower forms. Gravity has no such medium, no conduit through which to waste what it shapes. Its waves, once born, can travel across the universe unaltered, carrying the pure curvature of space-time itself. This inefficiency as a force translates to perfect efficiency as geometry. The less it interacts, the less it loses, and the more completely it preserves the total balance of energy in the cosmos. In the smallest scales of quantum mechanics, gravity seems almost absent. The particles that govern the other forces, photons, gluons, W and Z bosons, exchange energy rapidly, their interactions tangled and chaotic. Gravity's equivalent, the hypothetical graviton, has never been detected. If it exists, it must interact so weakly that even the most sensitive instruments cannot reveal it. This near invisibility is another expression of gravity's perfection. It does not need to show itself in the noise of quantum exchanges, because its presence is already encoded in the structure of space-time. Gravity is not a force acting within the universe. It is the stage upon which forces act. When we examine how energy moves through this stage, we find that gravity's efficiency is woven into the very logic of the equations. The curvature of space-time depends directly on the energy and momentum of whatever it contains. Every bit of mass and radiation contributes to the bending, and the bending in turn determines how that energy moves. The relationship is exact, symmetrical, and self-closing. No surplus, no deficit. Because space-time includes both energy and its negative counterpart in curvature, the total can always sum to zero. This balance is what allows gravity to shape the cosmos without ever spending anything from itself. Even the formation of black holes, those cosmic abysses where gravity reaches its extreme, illustrates this rule. As a star collapses under its own weight, the potential energy lost by the falling matter becomes radiation and kinetic motion. When the collapse completes, the resulting curvature traps everything inside a horizon, yet no energy disappears. The black hole's mass encodes the total energy of everything that fell in, and the geometry outside adjusts seamlessly to contain it. From a distance, the universe remains perfectly balanced. Gravity has transformed, not consumed. If we compare this to the other forces, the contrast is profound. Electromagnetism fills space with radiation, scattering its energy as light. The nuclear forces bind and break, releasing torrents of heat and particles. Gravity does none of these things. It governs the largest scales without producing noise. It is the silence that allows the music of the universe to be heard. Its weakness keeps it pure. Were it stronger, space-time would tear itself apart with every shift of energy. Were it weaker, structure would never form. The gravitational constant's minute value is the tuning of the cosmic instrument, the perfect compromise between stillness and motion. There is a deep symmetry in this duality. Gravity is the weakest of the four fundamental interactions, yet it controls the fate of stars, galaxies, and time itself. It shapes the paths of photons, it decides how the universe expands, and it dictates how it will end. Its subtlety is its strength. Weak coupling means minimal interference, minimal resistance, and near-perfect conservation. It is as if the universe, in its wisdom, designed gravity to be strong enough to organize matter, but too gentle to waste energy doing so. The result is a cosmos that runs effortlessly, without decay of motion, without exhaustion of form. The balance between strength and weakness is not just a numerical curiosity, it is a philosophical statement about the nature of power. True strength, gravity teaches, does not consume, it endures. The electromagnetic force dazzles, but fades. The nuclear forces blaze, but die. Gravity simply persists, unchanged and unchangeable. It requires nothing and gives everything shape. Its gentleness is the reason stars have time to live, planets time to form, and consciousness time to emerge. The weak force becomes the strongest influence, not through domination, but through patience. On the largest scales, the universe behaves like a single system, governed by this principle of quiet persistence. Galaxies orbit within clusters for billions of years. Clusters drift through the cosmic web without losing cohesion. Even the expansion of space obeys gravity's rule, slowing and accelerating in perfect proportion to the energy density of the cosmos. Weakness here does not mean fragility, it means precision. The universe does not struggle to maintain its form, because gravity's equations guarantee that form will endure. If one could watch the cosmos from the outside, its motion would seem effortless. Galaxies spiraling like leaves in a slow whirlpool, stars drifting through lanes of dust, space itself expanding like a calm breath. Nowhere is there evidence of fatigue or expenditure. The weakness of gravity allows the universe to move with infinite grace. No part of space-time ever burns out, because gravity's influence cannot be spent. It is not a currency that runs low, but a geometry that renews itself continually. The idea that the universe is powered by weakness is both humbling and profound. It means that endurance and stability arise not from force, but from balance. Gravity's subtle pull is the signature of a cosmos that values conservation above all else. Every atom and every star participates in this equilibrium, guided by a field so faint it can barely be measured, yet so absolute that nothing can escape it. The force that can bend light, warp time, and sculpt the destiny of galaxies is the same one that allows an apple to fall gently to the ground. Weakness and power, silence and creation, fragility and permanence, all are the same truth written in the language of space-time. In the end, gravity's paradoxical nature explains why the universe endures. It is weak enough to prevent destruction, strong enough to bind everything that exists, and so perfectly balanced that it can carry energy and motion across eternity without loss. It is the only phenomenon that can be both infinite and effortless. The weakest of all forces is the foundation of all order, the silent architect that keeps the cosmos whole. Through its gentleness, it achieves what no other force can, eternal strength through perfect efficiency. In 1995, physicist Ted Jacobson proposed something remarkable. He suggested that Einstein's equations, the same ones that describe how space-time curves, could be derived not from geometry, but from thermodynamics. In this view, gravity is not fundamental at all. It emerges from the laws of heat, energy, and entropy. If true, this means that the universe's most mysterious force is actually the expression of equilibrium on the grandest scale imaginable. Gravity, the silent architect of galaxies, might be nothing more than the universe's way of keeping its own temperature balanced. To understand this, imagine space-time as a kind of fluid. Every region, every tiny patch, carries information about energy and momentum. When that information shifts, space-time adjusts its curvature, just as a fluid surface ripples when disturbed. Jacobson realized that if you impose the laws of thermodynamics, the flow of heat, the exchange of energy, and the increase of entropy, upon this fluid-like space-time, the familiar equations of general relativity emerge naturally. The connection between heat and gravity, once thought metaphorical, is in fact literal. Einstein's equations are simply the universe's equation of state. This idea did not come from nowhere. 2 decades earlier, Stephen Hawking and Jacob Bekenstein had already shown that black holes behave like thermodynamic objects. They have temperature, they have entropy, and they radiate energy slowly into space. The entropy of a black hole is proportional not to its volume, but to the area of its event horizon, a clue that information in the universe is stored holographically, on surfaces rather than in volumes. If even black holes, the most extreme gravitational entities, obey thermodynamic rules, perhaps all space-time does. In ordinary systems, entropy measures disorder, the number of ways a system's energy can be arranged. When heat flows, entropy increases. In the gravitational context, entropy measures the amount of information hidden by horizons, boundaries beyond which we cannot see. The event horizon of a black hole is not a physical surface but a limit of knowledge. The more energy trapped inside, the larger the horizon, and the greater the entropy. This connection between geometry and information suggests that space-time itself stores knowledge about what it contains. The shape of the universe is the record of its own thermodynamic state. The brilliance of Jacobson's argument was in showing that gravity arises naturally if space-time seeks thermal equilibrium. When energy moves between regions, space-time adjusts its curvature to maintain balance. What we call the gravitational field is simply the geometry required to keep the flow of information consistent with the laws of thermodynamics. In other words, the bending of space-time is not the cause of energy flow, it is the result. Gravity is the geometry of equilibrium. This realization transforms the way we think about dissipation. In most systems, equilibrium is reached through loss. Heat radiates, motion slows, entropy rises until balance is achieved. But space-time, being the entire system, cannot radiate energy outward. There is no outside. It must maintain equilibrium internally. That is why gravity appears dissipationless. The universe cannot lose energy because there is nowhere for energy to go. Every process that increases local entropy corresponds to an adjustment in curvature that preserves the global balance. This insight explains why space-time seems so serene despite the violent events within it. When stars explode, when galaxies collide, when black holes merge, enormous amounts of energy are redistributed. Yet space-time itself does not burn or decay. Its geometry changes smoothly to accommodate the new distribution, restoring equilibrium instantly. In this sense, the universe is always in a state of thermodynamic balance. Local fluctuations occur, but the whole remains steady. Gravity is the mechanism that ensures this cosmic calm. Even black hole evaporation, a process that seems to defy conservation, ultimately respects this rule. As Hawking radiation leaks from the horizon, the black hole's mass decreases and its temperature rises. The energy carried away in radiation matches the decrease in gravitational binding energy. The total remains constant. Nothing is lost, even as the black hole fades. When it finally vanishes, the energy it once held is returned to the cosmos as pure radiation. Gravity, once again, completes the cycle without waste. To see the full beauty of this idea, consider the expansion of the universe. As space stretches, the energy density of matter decreases. Yet the total energy, when gravitational potential is included, remains unchanged. The universe expands not by consuming energy, but by rearranging it. The thermodynamic balance extends to the cosmos itself. Every change in temperature, pressure, or density corresponds to a shift in curvature that preserves the grand equality. Gravity is the bookkeeping of the universe's heat. Some physicists have taken this reasoning further, suggesting that space-time itself may be a thermodynamic construct, an emergent phenomenon arising from microscopic degrees of freedom we cannot yet see. In this view, the smooth continuum of space-time is like the surface of a lake, while its true nature lies in the unseen molecules beneath. Just as temperature and pressure emerge from the motion of atoms, gravity emerges from the statistical behavior of underlying quantum information. The universe we experience may be the large-scale illusion of countless microstates averaging into smooth geometry. If this is true, the dissipationless nature of gravity becomes inevitable. In thermodynamics, equilibrium systems do not waste energy because they have already reached maximum entropy. Space-time, on cosmic scales, is already in such a state. It may fluctuate locally, through collapsing stars, expanding voids, or gravitational waves. But the overall configuration remains perfectly balanced. The universe's energy is conserved because it is encoded in geometry itself. To lose energy, space-time would have to change its total information content, which it cannot do. Information may rearrange, but it cannot vanish. This connection between gravity and thermodynamics also reveals a profound philosophical symmetry. Heat, once thought to be mere molecular motion, turns out to describe information flow. Gravity, once thought to be mere attraction, turns out to describe the same. Both are languages of balance, one at the atomic scale, the other at the cosmic. The second law of thermodynamics, which declares that entropy always increases, is not a statement of decay, but of order on the largest possible stage. It is the reason the universe continues to evolve without falling apart. When Einstein wrote his equations, he may have unknowingly described not just geometry, but the thermodynamic behavior of information itself. Space-time bends to equalize energy, just as gases expand to equalize pressure. Every event in the universe, from the fall of a pebble to the merger of galaxies, is a microscopic correction in this grand equilibrium. There is no fuel burned, no energy spent. The dissipationless perfection of gravity is the reflection of a universe that knows how to balance itself at every scale. And so, gravity's silence is not emptiness, but temperature in perfect balance. Its curvature is the thermal geometry of existence. Every motion is an adjustment in the cosmic equilibrium, every orbit a sign that the system is stable. The same equations that describe the heat of atoms describe the calm of spacetime. The universe does not lose energy because it cannot. It is the equilibrium. Gravity does not act, it equilibrates. The fabric of spacetime is the thermodynamic perfection of reality itself. In recent decades, physicists have begun to glimpse a truth deeper than geometry, that gravity may not be fundamental at all, but a form of information processing. The universe, in this view, behaves like a vast computer, with spacetime itself acting as the network through which data moves. Every quantum of matter, every photon, every fluctuation carries a piece of information, and the curvature of spacetime reflects how that information is organized. Gravity, then, is not a force pulling objects together. It is the flow of information seeking balance. This idea first took root in the holographic principle, a bold insight that emerged from the study of black holes. When a black hole forms, the information about all the matter that fell into it seems to vanish behind its event horizon. Yet Hawking radiation suggests that black holes evaporate, raising a terrifying question. If they disappear, what happens to the information they contain? Quantum mechanics insists that information can never be destroyed. Somewhere, somehow, the data must be preserved. Physicists discovered that the amount of information stored within a black hole is proportional not to its volume, but to the area of its event horizon. This means the universe behaves like a hologram. The three-dimensional world we experience may be a projection of data encoded on a two-dimensional surface. From this revelation came the suspicion that gravity itself might be an emergent property of information. If the geometry of spacetime depends on how energy and matter are distributed, and if energy and matter are just patterns of information, then curvature is the result of those patterns changing. The universe does not compute gravity separately. Gravity is the computation. As information rearranges, spacetime flexes. When we say mass curves space, we are describing how concentrated information warps the structure of reality. The Dutch physicist Erik Verlinde proposed in 2011 that gravity is an entropic force, not a fundamental interaction, but a statistical consequence of information trying to reach equilibrium. Imagine a particle near the edge of a region of space that stores information about its position. As the particle moves, the distribution of information changes, producing an entropic gradient, a difference in the number of possible microstates. This gradient manifests as a pull, which we interpret as gravity. In this view, an apple falls not because it is attracted by Earth's mass, but because the universe is reconfiguring information to maximize entropy. This interpretation connects gravity directly to the second law of thermodynamics. The universe evolves toward higher entropy because that is the most probable state. Gravity ensures that matter clumps, stars ignite, and structures form, all steps that increase the total number of ways energy can be arranged. What we perceive as attraction is the cosmos reorganizing its information in the most efficient possible way. This is why gravity never wastes energy. Information is never lost, only rearranged. In quantum theory, information and energy are two sides of the same coin. A single bit of information requires a certain minimum energy to exist, and every particle can be described as a pattern of bits evolving through time. If spacetime is made of these informational building blocks, then the smooth geometry of general relativity emerges as an approximation of countless quantum interactions. Each Planck-scale region of space carries data about its neighbors, and together they form a network, a kind of cosmic lattice that computes the unfolding of the universe. The curvature we observe is the visible trace of that computation. This notion finds support in the holographic duality known as ADS-CFT correspondence, which shows that a theory of gravity in a higher dimensional space can be equivalent to a quantum theory without gravity on its lower dimensional boundary. In this framework, the bulk geometry of spacetime is encoded entirely in the quantum entanglement of the boundary system. The shape of the universe is literally the structure of information. If entanglement changes, geometry changes. Space curves because data is being processed. Quantum entanglement provides the key to this connection. When two particles are entangled, they share information instantaneously, no matter how far apart they are. In recent years, researchers have found that the amount of entanglement between regions of a quantum field determines the geometry connecting them. The more entangled two regions are, the closer they appear in spacetime. If entanglement is reduced, distance grows. Gravity, then, could be the manifestation of information trying to maintain coherence across the universe. The cosmos stays connected through a web of entanglement that defines the shape of reality itself. In this perspective, every gravitational interaction is an information update. When a planet moves around the Sun, its position and momentum change, and the information about both bodies must be recalculated. The curvature of spacetime adjusts instantly to reflect that new configuration. This adjustment does not consume energy. It is energy. The system reconfigures itself through pure computation, preserving the total data content of the universe. No bits are lost, no energy dissipated, only rearranged according to the rules of geometry. This information-based view also explains why gravity is universal. Every particle carries information, and all information interacts through the same network. The reason all objects fall at the same rate, regardless of mass, is that gravity does not depend on what the objects are made of, but on how their information connects to space-time. The flow of information is constant, indifferent to material composition. Gravity is the one process that treats all data equally. To imagine the universe this way is to see it as a vast, self-organizing computer, not one built of circuits and wires, but of relationships and rules. The galaxies, stars, and atoms are not separate entities moving through space. They are data patterns within a single computation that runs on the geometry of existence. Every gravitational wave, every orbit, every fall is a signal propagating through that information field. The universe does not burn energy to think. It thinks by existing. What emerges from this picture is a new understanding of why gravity never wastes energy. Information, by the laws of quantum mechanics, is conserved. It can transform, entangle, or spread, but it cannot vanish. If gravity is information flow, then its dissipationless nature is inevitable. The total information of the universe remains constant, even as it changes form. Every black hole, every galaxy, every atom participates in this grand computation. Gravity's strength lies in its perfect accounting. At the deepest level, energy conservation and information conservation are the same statement written in different languages. What physicists call curvature, entropy, or entanglement are all facets of the same truth. The universe does not lose data. Even when matter collapses, even when light is absorbed, the information remains encoded in the geometry of space-time. Gravity's efficiency is not mechanical but informational. It preserves coherence across the entire cosmos, because the cosmos itself is coherence made visible. In this sense, the universe is not merely a physical system, but a self-correcting network of information. Its laws ensure that every process contributes to the maintenance of order within apparent chaos. The stars burn, the galaxies collide, the black holes evaporate, but the ledger of existence stays balanced. Gravity is the medium through which the universe remembers itself, translating every change into geometry, every geometry into meaning. To see gravity as information is to recognize that the universe is not running down, but evolving toward greater complexity. Entropy increases, but not as disorder, as diversity of configuration. Every gravitational act increases the universe's capacity to encode new information. The cosmos is not losing coherence, it is learning. In this way, gravity is the engine of understanding itself, the perfect, lossless computation of existence. For all its elegance, gravity occasionally appears to betray its own perfection. There are moments in the cosmos when it seems to leak energy, to hide information, to defy the principle of conservation it so faithfully guards. Nowhere is this more evident than in the mystery of black holes, the places where space and time curve so violently that the laws of physics seem to fold into paradox. Here, gravity becomes both the keeper and the destroyer of knowledge. When a massive star collapses, its core implodes under its own weight. Gravity crushes the matter so completely that not even light can escape. What remains is a black hole, a region bounded by an event horizon, a surface beyond which all information vanishes from view. From the outside, it seems as if the details of everything that fell in are erased. The universe, which elsewhere conserves energy and data perfectly, appears to lose track of what enters the hole. To the observer, energy remains accounted for, but information seems to disappear into silence. This is the famous information paradox. In 1974, Stephen Hawking showed that quantum effects near the event horizon cause black holes to emit faint radiation. Over trillions of years, this Hawking radiation, can cause the black hole to evaporate completely. Yet the radiation is random, carrying no memory of what fell in. If a black hole vanishes and the radiation contains no trace of the original data, then information is lost forever. A violation of the most fundamental rule of quantum mechanics. It was as if gravity, the most precise bookkeeper in the universe, had misplaced its ledger. For decades, this paradox haunted physics. Some argued that information truly disappears, that the universe forgets. Others insisted that gravity must find a way to preserve it, hidden somewhere beyond our understanding. In recent years, a new picture has emerged, one that restores balance without contradiction. The information, it turns out, is not lost at all. It is encoded in the very surface of the black hole, imprinted upon the event horizon itself. Each bit of information that falls in stretches the surface slightly, increasing its area. The horizon acts like a cosmic memory, storing every detail in a code too complex for us to decipher. This holographic view solves the paradox elegantly. The black hole's entropy, as discovered by Bekenstein, is proportional to its surface area. Every bit of information adds to that entropy. The event horizon behaves like a two-dimensional screen, upon which the three-dimensional contents of the black hole are projected. When the black hole emits Hawking radiation, the information does not vanish. It slowly leaks back into the universe through subtle quantum correlations. The process is unimaginably slow, but complete. Even in its most violent form, gravity keeps its promise. Nothing is lost. The discovery that black holes conserve information reshaped our understanding of spacetime itself. If information is encoded on surfaces, not within volumes, then perhaps the entire universe operates this way. The holographic principle suggests that every region of space is defined by the information on its boundary. What lies within is a projection of that data. The fabric of the cosmos is therefore a vast network of surfaces, each one carrying the code that generates the illusion of depth. When gravity seems to break the rules, it is only because we are looking from the wrong side of the hologram. Even gravitational collapse, the most extreme act of concentration, obeys the same logic. As a star contracts, the potential energy of its matter converts into radiation and curvature. The total energy remains constant, but the geometry becomes so steep that time itself slows near the surface. From the outside, it seems as if the collapse never finishes, as if the star freezes in time. In reality, the process continues beyond our view, hidden behind the horizon. Gravity does not destroy energy or information. It simply moves them beyond our observational reach. The universe's balance sheet remains correct. Only the entries are written in a language we cannot yet read. This perspective also illuminates the role of gravitational waves. When black holes merge, the violent collision produces ripples that race across the universe, carrying away energy in the form of space-time curvature. To an outside observer, the system loses mass. Yet this energy is not wasted or dissipated. It travels outward perfectly conserved. The waves spread across billions of light years without scattering or absorption, eventually passing through detectors like LIGO as faint vibrations in mirrors. Even in this act of release, gravity remains flawless. What leaves one system simply joins another. The deeper we look into these extremes, the clearer the pattern becomes. Gravity never truly breaks its rules. It only tests the limits of our understanding. What appears as loss or violation from one frame of reference is revealed as perfect balance when seen from another. The event horizon hides information, but it does not erase it. Space stretches, but energy is conserved. The universe expands, but the total remains zero. The laws are never broken, only concealed behind layers of curvature and time. Even the apparent chaos of the early universe follows this order. When space was dense and hot, quantum fluctuations in energy created tiny irregularities in the distribution of matter. Gravity amplified these fluctuations, drawing matter together into galaxies and stars. The universe did not lose energy in this process. It merely reorganized it, trading smoothness for structure. What looked like the birth of complexity was in fact the unfolding of perfect conservation. Every fluctuation balanced by another, every rise matched by a fall, every curve offset by its complement. At every level, from the smallest black hole to the cosmic web itself, gravity demonstrates an almost moral consistency. It allows transformation, but forbids loss. It tolerates change, but not waste. Even when it hides information behind horizons, it keeps that information intact, waiting for the universe to recover it in time. The paradoxes we encounter are not flaws in the law, but reflections of our limited perspective, the shadows cast by perfection too deep to perceive fully. If gravity sometimes seems to break the rules, it is only because the rules themselves are written across dimensions we cannot yet see. The universe is not deceiving us. It is revealing, layer by layer, that its order is far richer than we imagined. What looks like loss is storage. What looks like noise is code. What looks like silence is meaning beyond comprehension. In the depths of black holes, in the ripples of gravitational waves, in the expansion of space itself, gravity keeps the ledger balanced with infinite precision. From atoms to galaxies, the same principle holds. Nothing is wasted. The universe is a perfect accountant. Every particle that falls, every photon that escapes, every fluctuation of space and time adds up to the same eternal sum. Gravity is the system that ensures the equation of existence always equals itself. Even when it seems to fail, it succeeds more profoundly than any human theory could have predicted. The cosmos remains dissipationless because gravity, the keeper of geometry and information alike, never forgets. Across the silent span of cosmic time, everything changes and yet nothing is lost. Stars ignite and die, galaxies collide and merge, black holes swallow light and evaporate again. And through it all, gravity preserves the sum of creation. The more deeply we look, the more the universe reveals itself, not as a machine that runs down, but as a balance that endlessly rearranges its parts. Gravity is not merely the glue that binds matter, it is the grammar of existence, the rule that ensures every sentence the cosmos writes still adds up to meaning. In the beginning, the universe expanded from a state of perfect uniformity. Its total energy was zero. Positive energy from matter and radiation, exactly balanced by the negative energy of gravity. As space stretched, that symmetry persisted. Galaxies formed, stars burned, planets cooled, and yet the equation remained the same. Gravity, in its silent way, maintained the cosmic bookkeeping, adjusting curvature and time so that every transformation stayed consistent with the whole. Nothing was ever truly created or destroyed, only translated between forms. This balance is what allows the universe to endure. The stars that burn do not vanish into waste. They radiate light that travels across billions of light years, carrying energy and information into the void. That light bends through gravitational fields, redshifts with cosmic expansion, and one day may be absorbed again by dust or drawn into another star's formation. The process is endless and lossless. Gravity does not let energy fall into oblivion. It keeps the ledger open, allowing every photon a place in the story of equilibrium. Even entropy, often described as the measure of decay, becomes part of this harmony. The second law of thermodynamics declares that entropy always increases, yet gravity ensures that the universe never dissolves into uniform heat. By gathering matter into stars and galaxies, it creates regions where complexity thrives. Entropy grows globally, but order emerges locally. The universe balances chaos with creation, expansion with attraction, loss with renewal. Gravity is the moderator of this grand dialogue between disorder and structure. When we study the cosmos through the eyes of physics, we find that every equation whispers the same truth. The conservation of energy, the constancy of momentum, the symmetry of time, all are expressions of one deeper rule. The universe cannot waste itself. Gravity embodies that rule in its purest form. It does not act upon space-time. It is space-time. It does not consume energy to move matter. It defines how energy moves. It does not grow weaker or stronger with time. It adjusts to preserve equilibrium. The dissipationless nature of gravity is simply the mathematical signature of an eternal system. Consider the waves of gravity still echoing from the earliest collisions. They move through the universe with perfect fidelity, unblurred by dust or decay. They are the purest form of energy transfer, untouched by any medium. Even after traveling for billions of years, they arrive exactly as they began. Silent vibrations of geometry, carrying the imprint of cosmic memory. In this sense, the universe remembers itself through gravity. Each wave is a record of motion, a chapter written in the timeless book of space-time. If gravity were a force like electromagnetism, it would degrade, lose energy to resistance, and fade. But because it is geometry, it cannot. The shape of space-time adjusts precisely to every change in energy and momentum. There is no friction between space and time, no surface to rub, no medium to slow the motion. The entire cosmos moves as a single self-consistent system. Even the vast expansion of the universe does not diminish this perfection. As galaxies drift apart, gravity stretches with them, keeping the total balance exact. Philosophically, this reveals something profound about existence itself. The universe does not strive for efficiency. It is efficiency. It does not conserve because it chooses to. It conserves because it must. Gravity's dissipationless nature is the clearest evidence that reality is not random, but self-consistent. Every curve of space, every tick of time, every movement of matter participates in the same logic. The cosmos endures not because it resists decay, but because it embodies equilibrium. When we look at the night sky, we are witnessing this balance in action. The light from distant galaxies has traveled for billions of years, crossing the warped geometry of clusters, the cold emptiness of intergalactic voids, and the slow swelling of space itself. Yet it still arrives. The journey is not one of loss, but of translation. Energy, curvature, and time trade places seamlessly, guided by gravity's unerring arithmetic. The stars we see tonight are the evidence of a universe that wastes nothing. Even in the far future, when the last star has burned its final fuel, gravity will continue its patient work. Black holes will dominate, consuming what remains of matter, radiating their energy back into space through Hawking radiation, returning everything to balance. Eventually, the cosmos may become a sea of faint radiation, nearly uniform and unimaginably vast. But even then, the sum will remain zero. Gravity will have conserved the harmony, not through resistance, but through coherence. The silence that follows will not be death, it will be completion. To describe gravity as eternal is not poetry, it is precision. It does not age, it does not erode, it does not tire. While stars burn themselves to ashes and galaxies drift apart, gravity keeps the score perfectly. It is the only thing in the universe that does not decay, because it is not made of matter or energy, but of relation and form. Geometry cannot wear out. The space-time fabric may stretch, but its law does not weaken. The universe endures because the equation of gravity ensures that it must. This realization leads to a profound conclusion. Gravity is the universe's memory. It records every motion, every change, every exchange of energy. The curvature of space is a map of everything that has ever happened. The waves that travel through it are echoes of events long past, carrying the signatures of collisions, births, and deaths of stars. In this memory, nothing is lost, not a photon, not a fragment of mass, not a whisper of motion. The cosmos remembers all, perfectly and without waste. And so, when we step back to look at the grand design, we see that gravity's silence is not emptiness, but music too deep for sound. It is the rhythm that guides the dance of galaxies, the pulse that beats through space-time. It needs no fuel, no medium, no repair. It is the eternal balance of existence, the dissipationless perfection at the heart of reality. In the end, all things, stars, atoms, light and thought, obey gravity's simple creed: conserve, transform, endure. Energy flows, matter changes, space curves, but the total remains whole. The universe, wrapped in its own geometry, will continue forever, not in chaos, but in harmony. Gravity does not push or pull, it simply tells matter how to move. It never tires, never fades, never wastes. In a universe where everything burns, gravity is the silence that endures.